We're returning with study guide help on number 4 for Unit 6, and we're looking at this problem about temperature. And it's saying that at midnight, the temperature in a city is 6 degrees Celsius. So this is kind of like where we start. We're starting at 6. The temperature has been dropping. That's a key word. That's like a takeaway term. At a steady rate. That's another key term. Steady rate means there's going to be some multiplication by something going on. The rate is 2 degrees per hour. Okay, that means I'm looking for like a 2 times something. 2 times the number of hours. Well, in this particular question, it says write an inequality that represents t. Okay, t being the number of hours. So I'm looking for a 2t in my inequality because I know that I'm losing 2 degrees Celsius every hour. And t represents hours. So I know I'm going to have a 2t. I know I'm going to have a 6, right? And we're looking for the number of hours past midnight when the temperature is colder, okay, that's a key word, than -1 degree. So those are my key terms. I'm going to have a 6, I'm going to have a 2t, and I'm going to have a -1. The question is, how do they work together in the story? Whenever I'm given a story like this, I just like to start at the beginning and kind of, add, subtract, multiply, whatever I need to do to get to the end. And this story starts with 6. So that's what I want to do. I'm going to start with 6. And then it says that the temperature's dropping. It's like, well, I can represent a drop with a subtraction. And it's dropping at a rate of 2 degrees per hour, which I already know is 2t. So it's dropping at 2t. And then it's going to end up being colder. So that's a key word for smaller or greater. Well, colder means lower temperature. So I'm going to guess that I need a less than symbol there because that's my colder word. And it needs to be colder, smaller, less than what number? -1. Boom, shakalaka. There's my number 1. I've written my expression, my inequality. 6 minus 2t needs to be less than -1. Got it done. Now it wants me to draw a number line that shows all of the values of t, so all of the hours past midnight that make this true, assuming that it continually drops 2 degrees forever, which is not ever really going to happen, but that's what we're going to assume here. So we need to solve this for t. When we solve this for t, okay, I'm going to just rewrite it over here, okay, is less than 1. We're actually going to treat it like it was equals. So I'm going to rewrite that as equals. So when I go through my solving process, I first start with adding the opposite. I don't want to think of that as a positive 2. I take away the 6. And that gives me -2t is -7. Okay, and that gets rid of my 6. I got the 7 from that subtraction. And then to get t by itself, it's being multiplied by -2, so I divide by -2. And that says that t is positive 3½ That's, or if you worked it out, it might have been 3.5 on your calculator. So 3½ hours, anything past that, so like 3:30 or beyond, it's going to be colder than 1 degree. All right, so 3½ or greater, right? Less, it's not going to get that low. So you can kind of common sense that. But I'm going to find 3½. Here's 3. 3½ would be right about here. And, the hours past midnight, 1 hour past midnight, if it starts at 6 and it's losing 2 per hour, that's 4. And then another hour it's at, 2. And another hour it's at 0. So at 3, it's going to be at 0. We got to wait till about that halfway mark between 3 and 4 before it gets to our -1 point. And then any time past that, greater, it's going to be colder than -1, less than -1. 0 doesn't make this work. If I put 0 in t's place, okay, that just makes that go away, and it's saying that 6 is less than -1. That's not true. So I don't want to shade towards 0. That wouldn't make any sense. I shade away, open circle, because we want it colder, not equal to -1. So that's number 4 for you.